and then I'm out.
Welcome to Solve for Success. Hello, I'm Christopher Kenneally from Copyright Clearance Center. Today, CCC presents a special town hall program on the transformative power of data visualization. We're very glad you can join us today live on YouTube. Please share your comments and questions during the program by using the chat function on the right side of your screen. If you're not already signed into your YouTube account, you will need to sign in for Gmail. Our online audience spans the globe, across Africa and Asia and the Pacific, to the Americas and Europe. We welcome among us data scientists, epidemiologists, librarians, and knowledge managers, as well as publishers working in medicine and other research fields. I'm coming to you from outside Boston in the United States, where CCC has its headquarters. Location and occupation are just two of the myriad of data fields we work with each day. In this digital era, there is no shortage of data. How much data is there? Over 2.5 quintillion bytes of data are created every single day. And we are adding 1.7 megabytes of data every second, every day, for every person on Earth. While we hardly lack data, we can lack for data-driven models that organize our data-filled environment. Imagine how helpful it would be to visualize our town hall audience and to be able to explore the connections we share. We could begin to do that with a knowledge graph. Data visualization may be critical in the 21st century, but it is hardly new. 4 centuries ago, Flemish astronomer Michael Florent van Langren published the first known graph of statistical data. At the time, sailors and mapmakers struggled with determining longitude and calculating east to west distances. Van Langren's 1644 graph shows the wide range of estimates for the distance between Toledo, Spain, and Rome, Italy. I think you will agree that this graph tells a powerful story, much more persuasively than would any 17th century chart or even a 21st century spreadsheet. In the next hour, we will hear real-world use cases about how you and your organization can optimize data to enable innovation through visualization. And I want to tell you a bit about the guests on our program, all of them very well qualified to join us today and very happy they can do that. We'll be opening today with Dr. Maya Natarajan. She is Program Manager at Knowledge Graphs for Neo4j, the world's most widely deployed graph database, with headquarters in San Mateo, California. Dr. Natarajan earned her PhD in chemical engineering at Rice University in Houston, Texas, and she holds 5 patents. Dr. Natarajan has previously positioned technologies from blockchain to deep learning and beyond in a myriad of industries at various small and large companies. We're also happy to welcome from Munich, Dr. Alexander Jarish, who is head of data and knowledge management at the German Center for Diabetes Research. Dr. Jarish is co-initiator of the COVIDgraph.org project, a nonprofit collaboration of researchers, software developers, data scientists, and medical professionals, providing a platform for COVID-related scientific data. We're also happy to welcome from France, Toby Green, who is co-founder of Coherent Digital. In November 2020, Coherent Digital launched Policy Commons, a discovery service to help researchers and policymakers benefit from the work of top policy experts, publishers, nonpartisan think tanks, NGOs, and IGOs. Previously, Toby Green was Chief Operating Officer, Public Affairs and Communications for OECD, the Organization for Economic Cooperation and Development based in Paris. Also happy to welcome to the program, after the initial presentations, my own colleague from CCC, Lauren Tulloch. Lauren is Vice President and Managing Director for Copyright Clearance Center. She's responsible for CCC's corporate business unit, which includes corporate licenses, the Right Find product suite, and managed knowledge services. Now I want to be very happy to welcome to the program, and for all of us attending today from San Diego, California, Dr. Maya Natarajan, Program Manager, Knowledge Graphs for Neo4j. Hello, Dr. Natarajan.
Hi, Chris. I'm happy to be here.
Well, we're very happy you can join us, and you've got a presentation for us that will set the stage for our discussion and give us some really important background on knowledge graphs.
That is correct. So let me get started. So I'm going to start off with two very, very simple words. This is smoking and voting. And you're probably wondering what the connection is between these two words, right? They're definitely two different things, but they have one thing in common, and that is they can both be used for predicting, they can both be predicted using relationships. Let's take voting, for example. We can actually predict whether you're likely to vote based on whether your friends vote. The interesting thing is we don't need too much information about you. We don't need your age, your demographics, your gender, or any of those kinds of data. All we need to know is who your connections are and or who your relationships are, and use that as relationships are the best predictors of behavior. Now, it's no wonder then that my mom has always told me to choose my friends carefully and wisely, and I believe I've done a pretty good job of that. Next slide, please. All right, so why are connections in data important? Because they contain context and meaning. And context and meaning add so much to data. Now, context and meaning are not easy to analyze with just any kind of database. Traditional databases, typically known as relational databases or SQL databases, an example of which is Oracle, and we're all familiar with that, are used for analyzing structured data. What they do is they organize data as rows and columns, and they totally strip out relationships. And in that process, all context and meaning is taken out. So relational databases are really not good for analyzing connections. Next, we have NoSQL databases. These are for unstructured data, data such as audio, video, and text, your emails, your PDF documents, and if you are big on social media, your tweets. Those are all examples of unstructured data. NoSQL databases came about to handle big data, and they do a fantastic job of big data, but they don't do anything with relationships. So again, they are not very helpful when it comes to analyzing relationships. Lastly, we have graph databases. Graph databases were actually built to natively store and query relationship. They're meant for relationships. There may be a few of you in the audience who may not be familiar with graph databases, so let me explain a little bit more about them. For this, I'm actually going to hearken us back to our middle school days. Next slide, please. In middle school, we learned about bar graphs, pie charts, and scatter plots. I may be bringing some good memories for some of you, but not so good for others. Now, these are all examples of charts. They are not graphs. When we talk about graphs, we talk about them in the context of connections between entities. And entities are typically things like people, places, things, and events. A graph is really pretty simple. It consists of nodes, and we can think of these as nouns. These represent the entities that I just mentioned, the people, places, things, and events. And in this example, we have two types of nodes. We have the people node and we have the car node. And these nodes are connected together by relationships, the verbs. Okay, in this case, we have loves or lives with and drives or owns. Both nodes and relationships can also have properties that further describe them. So if we have to extend this analogy of a sentence, we have the nodes, these are nouns. We have the relationships, those are the verbs. And then we have the properties, which can be thought of as adverbs or adjectives, basically further describing the nodes and the relationships. All right, so a graph is just a way of connecting data by nodes, the nouns and concepts, with each other via relationships, the verbs. And this model actually allows us to query and analyze the data. And that's where a graph database comes into play. Next slide, please. So there are different kinds of graphs, from the simple to the sophisticated. A simple graph is a graph of people. Okay, perfect examples of these are Facebook and LinkedIn. We're all very familiar with this because we use them on a daily basis. Next, we have the transaction graph. These are slightly more sophisticated than the people or social graphs. An example of this is when people buy items, when they return items, or they look for items on a website. Again, based on this, we can make predictions about what you'll buy next. Of course, which example would I choose for this? But Amazon. And when you buy from Amazon, I'm sure you've seen recommendations that come up, that pop up, that that are based on what you've just purchased, or that or on things that you may have been browsing for or searching for most recently. All right, you can also get super sophisticated with graphs and use knowledge graphs. And this is where heterogeneous ideas and concepts are linked together in context based on how they're related to each other. This is a little harder to understand, but we're very fortunate to have our next speaker, Dr. Alexander Jarish, who is actually going to talk about the COVID-19 knowledge graph. And it's very timely, of course. We're living through this pandemic. And what Dr. Jarasch has done is brought different concepts and ideas together to help us understand the COVID-19 pandemic better. So what all these three graphs have in common are the connections. And the graph allows you to see these connections natively and intuitively. Next slide, please. All right, this slide is a little intense, so I'm going to walk you through it. It's all about querying and analyzing your data in a graph database, and it can range from basic to really complex. So let's start off with the basic and work our way to the complex. Queries are basic. It's just like asking a question. And we use a Neo4j proprietary language called Cypher to query our database. Or we can use graph algorithms. These are predetermined formulas, and they're based on network science techniques that have been around for a very long time. Here we have PageRank as an example. Now, PageRank was invented by Larry Page, yes, of Google fame, in I think in the 1990s, and that's how Google search worked. Now we have over 50 algorithms in our graph data science library, including algorithms such as community detection, centrality, similarity, and many, many more. Lastly, we have embeddings. And these are used for feature engineering and machine learning. We also have graph-native machine learning, and very simply, graph-native machine learning means computing machine learning tasks within a graph database. I just want to point out here that Neo4j is the only graph database company today that can do graph-native machine learning. So we're very unique as far as that's concerned. Next slide, please. All right. Graphs lend themselves to a number of use cases. Basically, any use case that involves relationships. Here are some examples of our most popular use cases. Fraud is a classic graph use case example. We also have real-time recommendations, risk and compliance, master data management, and identity and access management. Now, these are the use cases that we've seen for the last 10 years. It's our bread and butter stuff. We do this day in, day out. What we've seen this past year is a surge in the use of graph databases for analytics and machine learning use cases, especially in the context of knowledge graphs. In fact, one thing we've noticed is that all our data science projects start off with a knowledge graph, and knowledge graphs enhance all stages of the machine learning workflow. So it's not surprising that we're seeing the surge in the combination of these two disparate technologies. So what all these use cases have in common are relationships, and graph databases are the only type of databases that take relationships into account. Next slide, please. So it's no wonder then that Gartner predicts that by 2025, graph technologies will be used in 80% of data and analytics innovations. What Gartner is telling us here is that everything is connected, and so graphs are everywhere. I'd like to finish off by saying, and of course this is tongue-in-cheek, so please take this with a sense of humor. If you thought relationships don't matter, think again. They're more important than they've ever been. And we have our third guest today. Very fortunate to have Toby Green, who will share with us the Better in Life Index. And of course, an important part of that framework is, you guessed it, relationships. So I stop with that thought, Chris, and I'm ready for any questions you may have.
Well, thank you very much, Dr. Maya Natarajan with Neo4j. And you're right, when you started talking about graphs, I had flashbacks to fourth grade. But what I did remember I liked a lot in fourth grade was space, was NASA. And I know that Neo4j has worked with NASA and on something they call the Learned Lessons Database. It's one of those graphs for good that yes, you are particularly fond of. And the point there is that NASA takes all kinds of data from the various missions they have in order to be able to notice patterns, to understand what is happening, what works, what doesn't work, so that the next time there's a launch, things go according to plan. And I think why that's interesting to this audience is these are not just about activities that you engage in the rest of the world with, right? You know, your customer relationships, you spoke about your relationships to even to the data. But here at NASA, it's about the relationship to their own work. So we can use knowledge graphs to benefit our work internally as well as for our external relationships. Do I have that right?
I'm sorry. That is so correct, Chris. You're absolutely right. At Neo4j, we have two aspects. We have the business use case applications, and then we have graphs for good. And one of the graphs for good that you pointed out, Chris, is the lessons learned database at NASA. And you know, just to quickly tell you, these are lessons learned from all their past tests and missions, both successful and unsuccessful. And these are mined and used in the planning of future projects and expeditions into space. And this was the case with Perseverance, you know, the Mars rover just a few weeks ago, or was it over a month ago? You know, we're so pleased that we were able to play a very small part in getting Perseverance to Mars. But another graph for good that I'd like to mention is the work that is done by the International Consortium for Investigative Journalists. This is the ICIJ. They use the Neo4j knowledge graph for their investigative work. You know, their work on the Panama Papers, which was really like a leak of over 10 million documents, showing how rich people exploited various secret offshore tax regimes. That piece of investigative work actually won them the Pulitzer Prize in 2016. And you know, similarly, I think this was last year or 2 years ago, they also uncovered the Paradise Papers. So they're doing a lot of good work in you know, using the Neo4j graph database. And again, you know, this is an important part of what Neo4j does. We do a lot of graphs for good. I won't go into too much detail about the COVID-19 knowledge graph, because that's what our next speaker is going to talk about. But that's another example of a graph for good as well. And like I said, very pleased that we're doing a lot of work in just not with businesses, but also a lot of work for the good of mankind. Let me put it that way.
Indeed, and Dr. Maya Natarajan in San Diego with Neo4j, thank you so much for joining us. And you mentioned the ICIJ, and you know, it's common to think of data scientists, but today we have to begin to think about data journalists as well. It's a really important point. Again, thank you so much. Thank you so much, Dr. Natarajan. So we want to join or have joined us now for the program from Munich, Germany, Dr. Alexander Jarish. He is head of data and knowledge management at the German Center for Diabetes Research and co-initiator of the covidgraph.org project. Welcome, Dr. Jarish.
Hello and welcome. Thanks for the invitation. I'm happy to be here, yes.
Well, we're very happy you can join us, and Dr. Natarajan has teed up the COVIDgraph project so well, but we're looking forward to more of the details. So tell us about it, please.
Exactly, and thank you for this kind introduction. And that was, the perfect introduction to my kinds of studies and daily work. As you might know, and I guess we have that in all our businesses, people are challenging the amount of information they have each and every day, especially when it comes to literature and connecting that in your mind with other information that you get. When we focus here on the left side, we have two scientists, maybe in my home institution, but maybe these are two scientists all over the world, and they are talking. And the one is asking, did you read about this interesting paper about COVID-19 and Gene X? And the other person says, oh, no, haven't read that yet. And oh, this publication reveals that the diabetics have a higher risk of getting infected. Oh, yeah, I knew that. and the other person asked, did you know that protein Y is mentioned to cause lung diseases? And the other person says no. So we have some answers in our mind, but many things we don't know. And this is the challenge here. It gets more and more that we don't know. And this is like pointing you to the right side. I guess all the scientists cannot cope with literature. They cannot cope with each and every database identifier, knowing if AD, the abbreviation is for Alzheimer's disease or alcohol dehydrogenase, or if there are some long COVID complications, or what is P881208. So what is that? Is it an identifier? Is that a date? Is that, this is the challenge that we face. And when we give you one example here, in the first 6 months of the COVID crisis, there were 128,000 scientific publications about COVID-19, and just about COVID-19. So nobody is ever going to read that, and nobody is ever going to connect that in their mind with all the other information that we have on COVID. Next slide, please. And this is why we started to use a technology called knowledge graphs to transform a text or information from text from other databases into a graph, so a network that connects all the bits and pieces together so that the connections, and this is what Maya talked about, these connections get visible and we can deduce more information from that. And in this example here, we have on the left side an abstract where we use natural language processing, so NLP, to automatically read and automatically annotate words, entities in a text, and bring that into this knowledge graph on the right side. Next slide, please. With this, we are spanning a knowledge graph that is extremely huge. And when I give you an example here on COVID graph, we have more than 1 billion nodes that are connected by 4 billion edges. So imagine how much information that is, and that has to be queried, that can be traversed, and where we see connections now that haven't been seen before. And in this example here, we use the GDS library from Neo4j called the Graph Data Science Library, where we have the Google PageRank algorithm that was already introduced. So we use that algorithm to automatically ask the graph, what is the most prominent gene that is connected to COVID? And in this example, we get the answer back within 2 seconds. This is called ACE2. That's a gene and that's a protein. And this is here on the in this picture, the pink node that we have. And all the connections to these slightly, let's say, cyan or blue nodes, these are publications that are mentioning this gene. And so we could identify within seconds what is the most prominent and most important gene about COVID-19. And I'm going to show you now that this is not a static view of a database or like a screenshot. This is really interactive, it's scalable, and this is very, very helpful for users that are non-computer scientists and they try to explore this graph with all its information. And with this, I'm coming here to a live presentation. What you see here, we enter ACE2 as a gene, and then it pops up here, this gene in pink, and we can zoom on that, seeing all the publications. We can do a right mouse click. So what is connected to this node here? We have some RNAs that are connected to that are here connected to their coding proteins. And we can click on these proteins here and deduce any information. So we can interactively traverse the graph. We can see interesting patterns, interesting results that come up, and we can directly interact with the graph in having a data visualization as well as algorithms that help us to traverse this graph because it's so huge. Okay, with this, we go back to our next example, what we can do with knowledge graphs. In COVID graph, we used a data set from meltwater, which has some clinical trials. And these clinical trials of COVID, they were a part of some press releases about that. And Meltwater did natural language processing, sentiment analysis. So is that press release positively, negatively, or maybe neutral, talking about a specific clinical trial? And we use this traffic light colors here, like in green, in red, and in yellow, if this is negative or positive. And what come up is a very interesting example here. This is connected to the drugs that were given in these clinical trials here. And on the right side, we see hydroxychloroquine, and these are connected to rather press releases talking about clinical trials rather neutral up to negative. Well, on the other side, we have a cluster of remdesivir, the other drug, and all these press releases were talking rather positive than neutral about a clinical trial to that. So you can see that we can do data analysis and also data visualization and on many different levels, and can make data visible, interactable, and also touchable for the users. Next slide, please. And this is an example that I showed you here. It's called COVID Graph. This was an initiative that started exactly 1 year ago. We are now 11 IT companies and some research companies like my organization, and we all are volunteering here on this project, making data for COVID-19 related diseases available, queryable for you. So that's free of charge. You can try that on your own. And yeah, we are happy to share. We are happy to collaborate with everybody. Yeah, and this is my presentation.
Well, Dr. Jarish, thank you so much for that. And of course, the point about COVID is that it has brought to the forefront of our minds everywhere in the world science and research and publishing. And it is remarkable how much we've all learned in the last year about what goes into understanding disease, what goes into developing treatments, and certainly what goes into creating vaccines for it. And I think that this is something that I want to ask you just very briefly about, which is the way that this kind of research today, the laboratory isn't simply a laboratory with beakers and test tubes. It's a laboratory on the computer itself with data.
That's totally correct, and that's why it's such a challenge to bring everything together. Most of our data is highly unstructured. It's very heterogeneous, so it's very, very complicated to integrate that into a relational database. And that's why we are turning this to a new technology called graph databases, and to integrate data, to connect data, but not only connect the data, but also connect the data with the people behind that, generating the data, and also interpreting the data. And I think this is very, very challenging, as I said, but also very, very rewarding, because completely new technology that we can use to get more insights into a disease or its long-term consequences. And this is what we have for many diseases, like for diabetes, we have long-term complications like stroke and heart attack and retinopathy. Also, COVID has a risk which is connected to diabetic patients. So everything is connected. And I guess not only the diseases are connected, but also the environment and the diets and your way of living. So that's why I think graph technology and knowledge graphs is the key technology to tackle that.
All right. Well, Dr. Alexander Jarish with covidgraph.org, thank you so much. And my next guest today has undertaken to make it easier to find and use content and data that's informally published online. We have a very brief video introduction now for Toby Green and Policy Commons.
Researchers, academics, and policymakers are working together to solve the world's most pressing problems. Yet their research, reports, data, and recommendations are scattered across the internet. They're hard to find, and they're at risk of disappearing. Policy Commons is the first platform to bring this body of knowledge together. And every month we're adding thousands more books, reports, charts, tables, and graphs to Policy Commons. You'll find new information and sources that you never knew existed.
And now we want to bring on to our program today to speak with us about what Policy Commons is doing and much more, Toby Green, co-founder of Coherent Digital and previously with OECD, the Organization for Economic Cooperation and Development. He joins me now from near Paris, France. Bienvenue au programme, Toby.
Well, thank you very much. And thank you very much for the commercial for Policy Commons, which was launched last November, and just about coming out of its beta phase. So yeah, we've come a long way.
Well, congratulations on that launch, and tell us about how data is factoring in this work to uncover these hidden materials and the hidden insights that lie there.
Well, the challenge is that Maya and Alexander have been telling us about huge data sets and data that's in effect that's digital, and therefore that needs mining. There's also data captured on pages of reports and in charts and graphs. And what I'm trying to do with Policy Commons is to build a system that can actually bring those to life. What I'm showing on the screen here, in fact, is something from 1854. John Slow was a doctor in London, and he was involved in a cholera outbreak in 1854. At the time, it was believed that cholera was airborne as a vector for the disease. They didn't really understand it, and they thought it was caused by bad air. This particular outbreak was really very serious. All the rich people left. Memories of what happened when the lockdown started. People evacuated the big cities with the current pandemic. But John Snow stayed and started to work on the data to try and see whether he could show what he suspected, which was that the cholera was waterborne. And so what he did was that he plotted the occurrence of cholera cases to the households in an area of Soho in London. And he managed to work out that there was a clear connection between the cases of cholera and people's accessing one particular water pump in Broad Street. And he actually very sort of controversially locked that water pump so that people couldn't get the water, in order to demonstrate that it was the water pump that was the cause of the cholera. So this was, in a sense, a very early attempt at test and trace. He was certainly recording the cases and tracing where it came from, but also a case of visualization of data, transforming knowledge and transforming the understanding of this particular disease. So if we can move on, we'll move on 1 year to 1855. If we can move on to the next slide. This is a slide put together by Florence Nightingale. Now, Florence Nightingale, I was brought up in England, and Florence Nightingale was the Lady of the Lamp. She was the sort of, we were taught that she was this wonderful nurse who cared for all the troops in the Crimea War. Well, she was a nurse, but she was actually also a data scientist, and she plotted the data of the causes of death in the British Army in the Crimea. And what you can see here is the pale grey, blue-grey, that's deaths from disease. The black is deaths from other causes, accidents and so on. And the red is deaths from wounds. And you can see very, very quickly that the British Army, the much higher risk of you dying of disease in the British Army than dying from the battlefield. Now, at the time, there was very little care for the soldiers. And the British Army and the government wasn't interested in caring for soldiers. Florence Nightingale made this chart. She took it back to the authorities in London, and using the data, she transformed the way that the medical care took place in the British forces, and saved thousands of soldiers' lives as a result. So this is another case of how a data visualization, very simple visualization, can really transform policy and transform people's lives. We move on to the next slide, please. As I said before, the content that we're putting into policy commons, and we're up to about 2.5 million reports now. We're pulling these in from NGOs and from IGOs, and this content is informally published. It's in PDF form normally. Some of it is very poorly produced. It doesn't have the benefit of having been produced by professional publishers. And this content is incredibly hard to mine and to find the information that's locked inside. So what we're doing, and so you can hear that this is a report from the EU, and it's a technical report, and it shows projected changes in water availability in Europe. Now, if you were looking for that, there's no way you'd find it simply by doing a search on Google or something like that. So what we're developing in Policy Commons is a tool that will actually find tables and find the charts and surface them in Discovery, so that this content can become discovered and be accessible. Can we move on to the next slide? So, and this is really, I mean, this illustration here, in fact, is from the period of John Snow. There's water everywhere and not a drop to drink because of the locking up of the water supply. And in a way, it's data everywhere, but not a number to be had, because the data is locked in the pages of reports and very, very hard to find. But it could be exactly the data that you need and the data that you're looking for to maybe help transform policy and make things better. So that's what we're trying to do with Policy Commons. Now, in my previous job at the OECD, if you don't know what the OECD is, it's a major international organization, and it's one of the biggest producers of socioeconomic data. And it's heavily used. There are 350 data sets at the OECD, and they're used to help develop better policies. One of the challenges that we had at the OECD was to build an index that would show the quality of life as opposed to the quantity of life. So famously, GDP is used to measure the performance of and the development of countries, and GDP basically is measuring money. It's how much money does a society create. So in a sense, you're measuring the quantity of life. Well, how do you measure the quality of life? And of course, that's very controversial. It's also subjective in terms of what one person could consider housing to be much more important than, say, a community, or vice versa. And so what we did at the OECD is we built an index where, in effect, we were putting the data in front of the user and allowing the user to make the changes to the data and to input their own view on top of the data in order to be able to generate their own personal index. Now, we can do that live now. If we cut to the web, here is the Better Life Index going live, and perhaps I could call on my co-panelists to help me build an index. So, Maya, housing. What do you think housing should? Do you think housing should be terribly important or middling important?
I think I'll give it a slightly more than middle, 6-ish.
How about that? Okay. All right, Alexander, would you like to do jobs? I can't hear Alexander. Chris, perhaps you could do jobs while Alexander.
Well, I was going to say, I'm going to guess we all need a job, so it should be as far over to the right as you can make it.
Okay, all right.
Here
so,
we go.
all right, Alexander, maybe you could pick up on education. Where do you think?
I would go to 70%.
70%. Okay, so that's about.
Well, it seems that Toby Green may have broken the internet there. Toby Green, we will have him back in just a moment. But I think where we're headed with this is an idea, I think, that is really a quite powerful one, is that we can see the entire world on a screen, on a graph. And there we have Toby back.
Hi, I'm back. I'm sorry about that. Even though we have fantastic broadband out here in the countryside, it went down. So we're now dongled on my phone. So I apologize for that. So where were we? Civic engagement. So, Maya.
I would say that's very important. Again, I'd give it an 8.
An 8,
on that.
okay. I think I seem to have. There we go.
There we go.
So, Chris, your turn. Life satisfaction.
Oh, I'm pretty big on that. I know in France they say that in the U.S. we live to work, but you work to live in France. So I'll go with 80% there.
Okay. Who's that? Alexander, work-life balance.
I would also put it to 80%. Yeah, Europe is quite into that.
And income, Maya. Do you think people need to have lots of income, or can you live frugally?
You know, I think we can live frugally. I would give it a 6.
Okay, all right, I'll put it there. So, Chris, on community.
Well, I'm supposed to say community is really important, right? But I think sometimes too privacy is also important. So let's put it in the middle.
Okay, we'll put it in the middle. The environment for Alexander.
I think the environment is extremely important. That's why I would put it to 100.
Okay, Maya, health.
Put it all the way up.
All the way up. Well, I think we got a pandemic on, so that's what I guess. And safety, Chris.
Oh, I think safety is pretty important, sure, but not 100%, maybe 90. Try that.
Okay, so there we are. So there we've done the index, and if we therefore this panel should go and move to Norway, because that gets the best marks with that particular set of weighting. If we didn't like Norway, we could go down under to Australia, or if we like volcanoes, we could go and live in Iceland. But we would want to go and live in South Africa, Mexico, or Colombia. So this is an index. It sounds like it's a bit of fun, but in fact, when this was put out, we built this about 10 years ago, and when it came out, it was huge. It got an awful lot of media coverage and it got significant attention. And the other interesting thing about the index is that because people can obviously interact with it, we actually captured the data of people interacting with the index and fed that data back to the research team at the OECD that looks at the quality of life, because in fact we found that there were definite patterns in different countries. People were weighting those things differently. And so there were definite, in some areas, some countries, housing just really wasn't very important at all. In others, it was terribly important. So so that the tool itself became a data generator for the research team, as well as being something that puts out. So that's the Better Life Index, and I think I'll stop there.
All right, well, Toby Green with Coherent Digital and Policy Comments, thank you so much. And we'll be coming back to our other panelists for a roundtable discussion, and we'll take on your questions as well. So if you can use the chat on the right-hand side of your screen on your YouTube channel there, just let us know what's on your mind. If you do have a question, if it's for one of the panelists, please indicate that. But just sort of for a few moments, I want to bring on my colleague from Copyright Clearance Center, Lauren Tulloch. She joins us now from near Boston, our headquarters for CCC. Lauren, very nice to see you.
You too, Chris. Thanks for joining. It's been a great discussion so far.
Well, indeed it has, and it's sort of reminding me that at CCC these days we look around at our world of data and we think we all need to become data scientists to sort of follow in those footsteps of Florence Nightingale. And you've been talking to our customers a lot recently about this sort of data first approach. And what do you hear from them? What are some of the challenges that they tell you about?
Well, at the highest level, I would put the challenges into maybe 3 categories. The first being that valuable data and content is often locked away in silos. And so it's difficult for our customers to fully organize and leverage it in the way that they would like to. So one of the challenges that they face is how to unlock that. And in some cases, it's locked away for good reasons, for security and privacy. But they want to find a way to unlock that and get it into technology like graphs so that they can fully leverage it. The second category I would say is the data itself, and that the data pipelines can be, the data is only as good, the knowledge graphs are only as good as the data that's inside them, right? So there's challenges with the cleaning of the data and making sure that the data pipeline is the best it could be. And then the last is kind of related to both of those, is that there are tons of sources of data, and as the previous speakers mentioned, the real value is actually in the connections between them. So what our clients are often telling us that they're looking to do is to be able to leverage both data publicly available, data that they license, along with their own internal proprietary data, and make the connections across all of those, so that they can identify things that they haven't been able to, connections they haven't been able to make up till now.
Right. So Lauren, we've been hearing about some of the use cases that Dr. Natarajan and Dr. Jarish are familiar with, from Mars to the smallest microbe. What are some of the use cases? Is there one in particular that stands out for you that is striking, surprising, illuminating of this topic?
Sure. We've of course talked with customers about a number of use cases, from safety monitoring to competitive intelligence, customer sentiment analysis. I think someone brought that up earlier. Another one is finding key opinion leaders in a particular area of study, particularly if that's a narrow area of study. But one that has jumped out of late is building on that key opinion leader, is actually not finding the key opinion leaders or the biggest experts from today, but those of tomorrow. So 3 to 5 years from now, the so-called rising stars of a particular field. So these are the folks that a leading R&D company would want to recruit potentially to join their organization, or identify other institutions that they might collaborate with in order to bring, discover new things and bring new things to light. And this is a little bit trickier than finding the experts in the field, because they might be buried a little bit further. You're not necessarily looking at the lead author of an article, but rather the contributors, not necessarily the head of a lab, but the up and coming postdoctoral or PhD students. And so that could mean incorporating information about grants, about funding reports, alongside things like published literature and patents and things like that.
All right. Well, so that gets to that predictive power of knowledge graphs that Dr. Natarajan was speaking of. That's right. All right. Well, thank you so much, Lauren Tulloch with CCC. And I want to bring back our panel for our roundtable discussion. Again, if you do have a question for anyone who's on our program today, please let us know about it in the chat. There, you can use your Google account and type it into the box on YouTube. And want to welcome back everybody: Dr. Alexander Jarish, Dr. Maya Natarajan, Lauren Tulloch, and I think we'll have Toby Green with us in just a moment. There he is. There's Toby. Dr. Natarajan, I'd like to go back to you, because you have told me that you see your role at Neo4j, as far as knowledge graphs are concerned, is as an evangelist. And in this evangelization that you're undergoing, or working on, I should say, what are some of the businesses and the research areas that you think may hold the best opportunities to find converts?
Thank you, Chris. Yes, I am actually responsible for knowledge graphs, and it's very interesting because as I heard Lauren talk about some of the issues that have come up, we've actually seen the same thing. And just to kind of get everyone on the same page as to what knowledge graphs are, we have a simple graph that I showed you, the transaction graph, which just connects data together. And the connection between those data, they actually give you context. Now, a knowledge graph takes this to the next level, where you have an interconnected set of data already. And then what we're doing is we're enriching that interconnected set of data with semantics, so that we can reason about the underlying data. So we're actually driving intelligence into the data when we use knowledge graphs. So what's exciting right now about knowledge graphs is that they can solve two kinds of big problems. One that Lauren mentioned, which is to unlock data silos. In fact, you can use knowledge graphs to actually bridge, you can use knowledge graphs to bridge data silos. That's one big area. But the one that is super, super exciting for me is using knowledge graphs for contextual AI. And I think this is, as I mentioned in my presentation, we've seen a surge in the use of knowledge graphs for machine learning and analytics. And so this kind of flows nicely with that. And so we have this other big umbrella that we're looking at Neo4j, which is knowledge graphs for contextual AI. And AI, of course, covers a lot of disciplines. It includes machine learning, deep learning, natural language processing. So it's an umbrella that holds everything under it, right? So we're not quite at the AI level yet, but what we describe as contextual AI is taking surroundings into account, and then where there is an adaptation to the different situations, and therefore AI behaves as expected, and it's explainable, especially in this day and age where machine learning or deep learning seems to be a black box. We're trying to use knowledge graphs to make it more explainable, and that's really important. But as far as Neo4j is concerned, which businesses and research fields? Well, machine learning plays a role in so many different fields. In the life sciences, where, for instance, or in healthcare, you can use it to detect tumors, right? In the financial world, you can use it for making for identifying investment areas. So there are many, and supply chain. There are so many uses. So almost every business uses machine learning, and we're seeing a rise in the use of graph technologies for machine learning. So I mentioned embeddings. These are AI learned formulas that are used in feature engineering. And the interesting thing is when you pair that with knowledge graphs enhance all phases of machine learning, from data sourcing all the way to modeling to analysis and production. Again, I bring it back to what Lauren had mentioned, that data scientists were interested in cleansing their data. Knowledge graphs allow you to actually, in the data sourcing stage, you can actually track data lineage, where the data came from, where, who's been using it, and where does the data end up. So you can track data as it moves through the machine learning workflow. And then if you go on to the second stage, which is modeling, you can actually use knowledge graphs to help you with feature engineering. What's exciting for me is that all of this has happened in a short space of time at Neo4j, probably in the last year or so. And most recently, we introduced our new graph native machine learning. This is, as I mentioned, computing machine learning tasks within the graph database. So we can actually do supervised graph machine learning within the Neo4j graph database. And it's quite conceivable that we may tackle unsupervised learning next. So, there's lots and lots of exciting stuff. And I'm going to do a little bit of a shameless plug, Chris, if you don't mind. I recently just wrote an article for DBTA Thought Leadership Series, and it's called Knowledge Graphs for Contextual AI. And I go into depth about all of this. So if anyone in the audience is interested, please reach out to us at Neo4j, and we'll make sure we get it to you.
All right. Well, Dr. Natarajan, thank you so much for that. And I see Dr. Jarish nodding his head about a lot of that. And one of the questions I think we all have is about how to make this happen, right? If there's the excitement around the possibilities, there's also the realities of organizations, whether they're research organizations like yours, Dr. Jarish, or businesses, or whatever they may be. And so this is about making sure you've got the infrastructure in place that will make it possible, hospitable for knowledge graphs. Dr. Jarasch, talk about that. Talk about the challenge around infrastructure.
Yes, thanks for that question. And I guess Maya did a really good explanation for knowledge graph is rather an infrastructure that is the prerequisite for artificial intelligence or machine learning techniques that usually everybody's talking about, and where usually all the money goes. And this is where we see a big challenge. Usually, the governments or funders, even foundations, are rather hesitant to fund infrastructure that is sustainable, long-term, and they rather go for funding projects on artificial intelligence or other projects. So this is the challenge that we face. That's why COVID Graph is based on only voluntary work, and I think yeah, it will be a big difference in the next couple of years. I guess the companies that do not tackle knowledge graphs, they will have severe problems, because everything is about data, everything is about knowledge, knowing what the market is, knowing what the competitors are doing, knowing what you can do with your data that is connected to your in-house data, to the public data, connected to your people. I guess this is this will be the big challenge. So infrastructure, investing in infrastructure and make data available or searchable. This is critical in the next couple of years, and this is what we see in the COVID crisis, definitely.
All right. Well, Dr. Jarasch, thank you so much. And one of my challenges as moderator is keeping us to time. And I think we've really had a tremendous discussion here, one that's been very informative. I think also illuminates the possibilities, which is really what we wanted to do with this town hall, was to get everybody as excited as you are, Dr. Natarajan and Dr. Jarish and Toby Green as well, about these possibilities. And so I want to close now and thank our panelists, Dr. Maya Natarajan, Program Manager at Knowledge Graphs for Neo4j. Thank you so much.
Thank you very much, and thank you for inviting me. This is, I actually had a lot of fun listening to everybody's talks, and I really appreciate it. Thank you.
Well, thank you indeed. Dr. Alexander Jarish, Head of Data and Knowledge Management at the German Center for Diabetes Research and co-initiator of the covidgraph.org project. Dankeschön, Dr. Jarish. Thank you.
Thank you very much for having me. It was wonderful to talk to you. Also to Toby Green, showing that data is interactive and that it's not static and abstract, so that we can touch data and that people and data can work together. I really like the discussion. Thank you.
Thank you. And Toby Green, co-founder of Coherent Digital and Policy Commons. Merci.
My pleasure. And yes, I think it's vital that data is useful, so we can actually change policies and make people's lives better.
Right. And finally, thanks as well to my colleague Lauren Tulloch, Vice President and Managing Director at CCC. Good to have you here, Lauren.
Thank you, Chris. I didn't unmute myself, but I enjoyed the discussion very much, and I really, it was great to hear from all the panelists.
Indeed. I also want to thank Haley Sund and Joanna Murphy-Scott for organizing and producing this town hall today, as well as the entire series, which began just a year ago. Check out our previous programs on copyright.com. Thanks as well to Rob Simon of Burst Marketing, who directed the video production for this live YouTube presentation. You can subscribe to our blog and podcast series, Velocity of Content, at copyright.com/blog. And you can tell us what you think about this program and about others that CCC is organizing by writing us an email to events@copyright.com. My guests today have demonstrated how data visualizations, especially knowledge graphs, can illuminate our understanding of the world. Dr. Natarajan spoke about graphs for good, and we saw how knowledge graphs are working to bring humanity out of the COVID pandemic and towards sustainable development. In 2021, we have computers to crunch data, but in 1900, the work of collecting data and creating knowledge graphs was left to a single remarkable man. In 1900, W.E.B. Du Bois was invited to the Paris Exposition to show how Black Americans had fared since emancipation, less than 40 years earlier during the Civil War. Du Bois evocatively documented for a world audience the adversity and achievement of Black Americans in more than 60 data graphs. And we have one we can show you that shows the rural and urban Black population of the United States state of Georgia. And I think you'll agree that not only is it informative, but it is artistic. It has a degree of flair. And I think we see that today in a lot of the knowledge graphs that we explored. A founder of the NAACP, Du Bois received a gold medal for the Paris exhibit. He returned to the United States and took a leading role in the American Civil Rights Movement for more than 60 decades more. We remember Du Bois as an author, activist, and sociologist. He deserves our acclaim as well as an innovative data scientist. For Copyright Clearance Center, I'm Christopher Kenneally. Goodbye for now.